Have you ever pondered the importance of biofuel and its potential in reducing our carbon footprint? As we grapple with the realities of climate change, it's crucial to explore all avenues of sustainable and renewable energy sources. One such avenue is the production of biofuel from unrendered animal fat. Today, we delve into this fascinating process. The journey to creating biofuel from unrendered animal fat begins with the critical act of gathering the raw material. This crucial element can come from a plethora of animal sources. It could be the robust fat of cattle, the thinner but equally potent fat derived from poultry, even the thick lard from pigs. These fats are typically procured from various sources like local butcher shops, slaughterhouses, or even your own kitchen. It should be noted, however, that the fat needs to be in its raw, unaltered state. Any kind of cooking or processing could the quality of the resulting biofuel. Once a significant amount of raw, unprocessed animal fat is collected, the process proceeds to the second phase, heating. This isn't your everyday heating, but rather a slow and controlled process known as rendering. The fat isn't subjected to rapid, high-intensity heat. Instead, it is exposed to a gentle, steady warmth. The ideal temperature for this process is around 200 degrees Fahrenheit. At this temperature, the fat doesn't burn but slowly melts, effectively separating it from any remaining meat or tissue. This phase isn't a quick one, but rather a process that takes patience and time. Depending on the quantity and the type of fat, it could take anywhere from a few hours to a whole day. It's a crucial step that cannot be rushed, as the quality of the rendered fat significantly impacts the final biofuel product. Thus, the process of turning animal fat into biofuel is not as simple as throwing a switch. It requires careful selection of raw materials and controlled processing techniques. The third step in the process, which is cooling and filtering, requires a certain degree of precision. After the fat has been rendered, it is left to cool down. The ideal temperature for cooling is around 70 degrees Fahrenheit. This allows for the fat to solidify without becoming too hard. It's important to maintain this temperature and let the fat cool at a steady pace to prevent the formation of undesirable crystals. Once cooled, the fat is then filtered to remove any impurities. This is typically done using a fine mesh strainer or cheesecloth. These filters are effective at catching small particles that may remain in the rendered fat. The filtration process might be repeated several times to ensure a pure end product. The product of this meticulous process is a clear, golden liquid, which is referred to as rendered fat. It should free of any particles and have a uniform, smooth texture. If performed correctly, the rendering process can yield a high-quality fat that is perfect for various culinary uses. The next step, the rendered fat, is subjected to a process known as transesterification. This process includes mixing the fat with an alcohol, most commonly methanol, and a catalyst. The catalyst is typically a strong like sodium hydroxide or potassium hydroxide. When the fat, alcohol, and catalyst are mixed together and heat is applied, a chemical reaction occurs. This reaction is known as transesterification, which breaks down the fat into two primary components, glycerin and methyl esters. The glycerin, being heavier, sinks to the bottom of the mixture, and the methyl esters, which is the biofuel, floats on top due to its lighter density. This reaction is a crucial step in the process, as it transforms the fat into a usable biofuel. The final step in the process is the separation of the biofuel from the glycerin. This is not as simple as it sounds, and involves a precise method of draining off the glycerin. The process begins by allowing the mixture to settle, with the heavier glycerin naturally sinking to the bottom. This separated glycerin can then be carefully drained away from the bottom, leaving the biofuel on top. This biofuel is a clear amber liquid that is ready for use in any diesel engine. Let's reiterate the journey we've embarked on. Creating biofuel from unrendered animal fat involves 5 key steps: collection of raw fat, heating or rendering, cooling and filtering, transesterification, and the sophisticated separation process just explained. Now, you might wonder why one would go all this trouble. The benefits of biofuel are actually quite impressive and multifaceted. Firstly, biofuel is a renewable source of energy, unlike fossil fuels which are finite. This means that as long as we have animals and the capability to render their fat, we have a sustainable source of fuel. This stands in stark contrast to resources like coal or oil, whose supplies are quickly being exhausted. Secondly, biofuel is carbon neutral. This means that it doesn't contribute to the increase of carbon dioxide in the atmosphere. When burned, biofuel only releases the amount of carbon dioxide that the animal absorbed during its lifetime. Therefore, it doesn't add to the overall greenhouse effect, unlike traditional fuels, which release carbon that has been locked away for millions of years. Lastly, biofuel is a perfect example of upcycling, turning waste materials into valuable resources. Instead of discarding animal fat, we can turn it into a useful product. Not only does this reduce waste, but it also provides an economic advantage, as what could have been waste now has value. In a world that is increasingly conscious of its environmental impact, the production of biofuel from unrendered animal fat offers a promising solution. It's more than just an alternative to traditional fuels. It's a testament to the ingenious ways we can harness the natural resources around us to create sustainable and renewable energy